Manish. Hi all, good evening and welcome to the Masterclass. And I have titled this talk as AI Practices in Digital Marketing. So what I want to convey, it's just a short talk, right? It's about 45 minutes, and so I'm going to give you an overview of the areas where we're going to have a lot of applications of AI emerging in the digital marketing space. So initially, for at least 20 minutes, I am going to give you a broad overview of where exactly are these applications emerging and what kind of applications there are. And you may not, you may or may not know much about digital marketing, the marketing functionality itself. So I will give you a little more into details into where we need technology like this and why it is important for us to use AI techniques. And then in the last 20 minutes, I'm going to go in depth into one project and show you how you can use AI technology to really get some insights for managerial actions, all right? So a little broad at the beginning, and then I'll bring it down like a funnel and then go into one specific area and then look at it in detail. I'm going to share my screen. I have some PowerPoint slides. And the way it will work is I'll probably go for about 10, 12 minutes. And then I'll stop there. And if I have any questions, I will answer. Maybe Shub, if you can, if you have your questions, you can put it in the chat and Shub can actually read it out to me, or you can also ask. But initially, I think, it's better to put it in the chat box so that Shub will take 1 or 2 questions and I will answer that. And then when I'm done at around 45 minutes into the talk, I'll have 50 more minutes for you to ask any questions and you can open up your mic and ask the questions, all right? So that will be the game plan. So I'm going to share my screen and I'll start off. So I have, as I said, I have titled this as AI Practices in Digital Marketing. And so without much ado, I will start looking at what we mean. So here is the field of artificial intelligence. So if you look at early 80s, 1980s, that is, you may have, early 70s and 80s, this field of artificial intelligence, neural nets and everything started emerging. And it's about the same time in the 60s and 70s, the field of machine learning was also. Now, the field of machine learning wasn't really put into the overall scheme of artificial intelligence. But I think right now, people think of artificial intelligence as a catch-all term, and then field of machine learning as being part of AI, and then deep learning, which is more into this high level of data volume and velocity, and analyzing that, we call it that deep learning, which has layers and layers and with high computing power that's needed to do those. So this will be so many of the techniques that people say in marketing, marketers are good at marketing themselves. So many of these consulting companies would say, oh, we use AI. Pretty much many times they mean machine learning, all right? And not too many applications are there for deep learning, but we will talk about that as we go along. Now, what are the promising applications in marketing? So basically, if you think about marketing, you have your environment, which consists of competitors and your consumers, of course, and your competitors, channel partners, and people, all the other context within which you are doing your marketing. And so if you were to look at the primary focus of companies tends to be the consumers. And so many of the analysis that is being done on these would be trying to understand what is the segment or clusters, because not every customer is the same. There could be segments and clusters of segments of customers who may have very different needs. And so many of the techniques that we use early on is trying to understand segmentation of the market and trying to identify the target that you want to send a message to, right? So the descriptive models of consumer behavior, identifying clusters and segments and focusing on segmentation and targeting is one of the biggest application of AI. And then and machine learning, I'm using the term very broadly. And then you have predictive models of consumer behavior, So, I have customers already in my database. I know how much they are spending over time. I can calculate their lifetime value. And I want to figure out, what will be their lifetime value going forward. So they have been with me for maybe 2 years, and how much are they going to spend with my company going forward? So I can do lifetime value calculations and predict that. And if people are coming onto my website, what is the probability of conversion? What is the likelihood of engagement? And people are, subscribing to my streaming service. What is the probability of churn? So many of these predictive models, what would consumers do? How will they engage? How will they, buy? And, whether they will convert or not if I give an offering. Are they going to stay on as a consumer? So all these things, what we call predictive modeling, we want to predict their behavior. And now the other thing that is very important these days is cross-device behavior. So, you're using your mobile, and then you go online, to your laptops, and maybe your watch. So, you have many devices across which you surf and you interact with companies. And so how does your behavior change from one device to the other? What kind of activities do you do on one device? What are the activities you do on another device? And if I have a data on this, can I say something about what happens when you switch from a mobile to a laptop, or when you come from a laptop to a mobile, to engage with me? So what kind of activities do you do? And when is a good time for me to really engage you with an offering so that you will close the deal, that you will convert? Right. So a lot of cross-device behavior, you can use many of that data that comes from cross-device behavior data. You can use machine learning techniques. And then, of course, recommendations. Recommendations have been bread and butter, applications of AI and machine learning, recommending products, services, movies, and what kind of advertisements do I have to recommend to this person who's coming to my website? How do I match? Can I really push certain kinds of messages to certain kinds of customers when they come to my website? How do I do the matching? And so many of these kinds of applications, again, we call it as a recommendation applications. Now, in B2B, lead qualification and prioritization is very important, right? So many people come, like, for example, even in our business school, we have lots of students who come and check out our website and try to apply to our programs or whatever, and then we may want to get their phone numbers or email and so on, and then we have a lead funnel, and we want to see how people are going through the lead funnel. So the one idea here is, for many companies, you have millions of customers that come to your website and check around and do things. Now, you don't have the resources to really go after every one of the millions of customers who come and check out. So you may have to have a model, a predictive scoring model, which will tell you that, based on the behavior that you see at the website of these customers, these are the people who you think are most likely to really convert. And so you should put your effort on them, right? So it will pay off, because if you have limited resources and you want to use the limited resources to cover the large amount of prospects you have, how do you pick the prospects? On what criteria do you pick the prospects? So predictive scoring is a very important model. And identification models. So acquiring prospects with similar characteristics as existing customers, look-like modeling. So, I have some customers who are already, I know their characteristics, demographics, and their buying patterns and behaviors on the website and so on. And when I go out and look for new customers, I want customers who look like these customers. So how do I do that, right? Identification, that is trying to target people who look just like my customer base. Automated segmenting of prospects. Instead of even having any person doing this, you want to automatically categorize prospects into different segments, and then have different levels of service provided to them. And then planning marketing interventions. And I will talk a little bit more about planning marketing interventions for different segments. Augmenting intelligence with experts from several experts. So, you have expertise resident in different people or in different machines. How do you combine them and use it in order to, use it on a particular application? right? And then you have chatbots these days. Chatbots are interacting with you rather than having a physical person interacting with you. So live chat would be done by chatbots, and you want to infuse chatbots with enough intelligence to really hold a nice conversation and take all your questions that you have and take you and put you into a particular bucket where the appropriate service can be given to you. So the applications are emerging, and some of them are already there, and these are all the promising marketing applications. The other thing is a big thing that is being pushed now, especially in digital marketing, is this hyper personalization, right? So what kind of message will be right for that particular person at the right touch point, right? So individual level, personalized, hyper personalized, right time at the right touch point with the right content. Now, of course, you essentially use data, combine the data that comes from all sources, online, offline, within firm, outside firm, and you combine all this information in order to understand how a particular customer may behave. So you predict what this customer is going to do, what kind of customer this is, and then you initiate some action, and then you see what the response to that action is. And then I determine, in a dynamic fashion, what to provide as an intervention for this customer, right? So at level one, you decide what to offer to who at what time, and then you do a monitoring in real time and take automatic actions. So these are all basically what is known as the reinforcement learning algorithms. So you give some interventions, see how customers behave, you learn from those interventions, and then you exploit those learnings in order to provide the right thing to the customers, right? And so in advertising especially, this is becoming very common. They are using these techniques in order to determine who to target, when, and then also what kind of ad copy should I show to this person, right? So trying to get an understanding of, even before you start interacting with them, you're trying to personalize what kind of messages you're sending. And so there are automatic systems that are being built. A lot of consultants work in this space, startups work in this space. And this is one of the emerging areas. Of course, this emerging areas is coming in contact with a lot of what I would say, privacy concerns, because the more personalized and more pinpointed you are, that raises customers, some kind of a, somebody is looking at what all the actions that I do, and here I am being super targeted with all the information which I didn't know they knew about me, right? So that kind of a pushback is happening, and so you have to take care of that. And some of these systems are designed in such a way that they don't do hyper targeting, but they do targeting. They know a lot about you, but they don't use all the information, but target to the extent that it will engage you, right? And so let me stop here. And is there any question? If you have, then I will, otherwise I'll go ahead and give you a little more.
So we have a question from Ankur.
Okay.
Yeah, it is, how do you do predictive scoring for new customers when prior history for them don't exist?
Yeah, it's a good point. The idea here is you got to have some, so if you're using some Bayesian models and so on, you have a prior, right? You essentially say, well, I assume that the distribution of this person coming in would fall into a curve like this, and I have to use that as my initial. And then that's what the real-time scoring does. The scoring will give you a few initial touch, some kind of interventions, and you learn from it, right? So since I don't have too much information, I have only a prior about what you could be, some prior information. That is my assumption. And then based on that, I give you some interventions, and those interventions, when you respond to it, then I get more information about what kind of responses you give. And that information can be used to update what your status is. So I'll be able to then do a better personalization going forward. Okay. All right. So let me give you another thing that is very common now, which is the multi-touch path to purchase. So I worked with a hotel here, Marriott. So we actually developed some systems with them. So what they would have is on day one, somebody will click on their email, promotion that Marriott has given, and they will come to their website, and they may not buy anything. And then the same day, they may go to TripAdvisor link and check out. And there is a referral link for Marriott from TripAdvisor. They click on it and they come to the website, and they don't buy anything also. And then on day 8, they go on Google and then search for hotels in Marriott or something like that, and then they end up buying something at the Marriott website, right? So the question that we have is, here is a path to purchase of a customer. We call this purchase funnel, and they have touched different touch points. And so one of the biggest concern in marketing, is what marketing campaign should get credit for this conversion. So I know the conversion happened on day 8. Now, who should I be giving this particular credit for? Now, if you think that the credit should be shared, how do we exactly value each of these touch points, right? So this is called the multi-touch attribution model, which is basically very, very common now. It's a big problem in digital marketing, because you are doing a lot of different things. People are getting, they have a customer journey, and when they have customer journey, they get touched by different things that you do, your email and your display ads, your search, everything else, and ultimately a conversion happens. So how are you going to, make that accounting for it? Why is it so important to make the accounting properly? Because if you don't account properly, the next time you put money on your budget, it is going to be off, right? Let's say by mistake, you give everything to Google and say, Google got the credit for this touch. And then you say, the email didn't play a role and TripAdvisor didn't play a role. And what's going to happen going forward is you're going to actually reduce the amount of budget allocated for email and TripAdvisor and put more money on Google, right? So using the last touch attribution. So you really have to get a good idea as to how these things play a role, how do they all interact and create this impact that you see on customers. So why do you have to? So the ideas here is that I have highlighted here. It says here, it allows marketers to optimize media spend to conversions, because that is a big thing in marketing. You want to not waste your money, how much money you put in marketing. Yesterday, we were sitting with our advertising company that helps Smith School of Business. And we looked at how we spent $650,000 on advertising, right? And we are not doing it very efficiently, because we are spending a lot of money on some search and everything, which doesn't have any results to show for, right? So what it really does is, it not only helps us to understand how to allocate the funds, but also looking at all the touch points that customers do. We know their behavior, and we also know how to intervene and what kind of things to give them going forward, right? So let me give you an example here from this Marriott case. So let's say I found 5 customers, and they all came through, customer 1, customer 2 came through paid search, customer 3 came through direct, 4 and 5 came through referral and display, right? And all these people converted. Now, if I were to give credit for all of them, I will say, okay, display gets 20%, referral 20, direct 20, paid search is 40% because it's 2 out of 5, right? And of course, email doesn't show up here, and I don't give any credit for email. But think about what happens when I look at their overall, the path to purchase. So this data can easily be, you can easily get this data, all right? Many vendors will provide it, and you can set up your own system to get all this path to purchase data. So here I see customer 1 has email here in the second part, and then has paid search, again gets another email, comes from paid search, and finally converts, right? So if you were to just take the last touch attribution, the impact of email, the supposedly impact of email doesn't get captured, because you're just looking at all these final conversions that happen, right? Now, we may also have customers who haven't converted. For example, customer 6 did not convert, customer 7 did not convert. Now, if you look at customer 7 and customer 1, you see here the only difference between customer 1 and customer 7 is this email that is missing here in the second spot, right? Everything else is the same, except that this person did not buy and this person did buy. So I can take this as a counterfactual of customer one, right? Assuming that customers are pretty much the same. Think of the customer one and same are exactly the same. One person gets email, one person doesn't get email. And the person who doesn't get email does not convert. The person who gets email does convert, right? And so immediately the fallacy of just using the last touch attribution becomes very clear, because this email does have some impact on, and so the data that you're seeing here, you have millions of customer journey data. Now these are all being fed into AI algorithms in order to understand how each of these touch points at the different positions really play a role in affecting conversions of customers, all right? And now those kind of insights are very useful, because then I can use that information and say, how much more do I have to, how much money should I put in paid search? How much money should I put in email, so that I can optimize my budget allocation? And not only that, because I get the insights into what works at what positions and so on. So I might then be able to take all this information and then create the campaigns that are the most optimal in terms of creating conversions with the money that I spend, right? So that's the idea here. So many of the companies, and this is I'm working with a few companies now. One of the companies that I sort of advising and working with is Amgen. For example, in Amgen, it's a pharma company. They put a lot of money on different things. They do a lot of brand advertising, TV, they do digital, they do Salesforce, they have retailers who go and talk to the doctors. They have TV, radio advertisement and print and others, right? And if you just look at their budgets, even within the digital channel is humongous. And they put money on social, display, and search. And so, all these things happen at different levels. For example, annually they decide how much money to allocate into these different things, and then semi-annually, then they will come up with how do I put money into digital and how much. And sometimes things are done at daily level, search and everything else. What kind of keywords I'm going to put money on, right? What are the campaigns I'm running? Some of the campaigns are done at weekly level, right? So you can see that this ecosystem is extremely complex ecosystem, because you really need to understand what your instruments are doing at the lowest level, but then you have to roll it up to the highest level, so that when you allocate the budget at the yearly or the semi-yearly level, you're doing the right thing, right? And it's not a simple problem. And this is where many of the machine learning and AI techniques are being used, right? So individual customers and touch points, understanding exactly, if I get all these information down, I should be then be able to use this information to say, don't target this doctor, because targeting this doctor with this campaign is not going to give you much of a response. Rather, put that effort in targeting this doctor who seems to be at the cusp. So if you put more effort on this doctor, that person is going to prescribe your medication to the patients, right? So that's the kind of idea. That is, how do I change? I don't want to just go with my gut feel and say I'm going to put money on everybody the same. No, if somebody is already prescribing, why waste money on them? I'll take the money off and then put it on somebody else who's not prescribing and try to move that person to prescribe. And so that's the kind of idea. At the margin, what am I going to do with it, right? So that information will come. You're using these techniques. So let me stop here and also ask if you have any questions before I move on to the next.
Yeah, we have one more question from Rakshit. It says, is there any way to statistically predict change of trends in terms of customer shopping habits?
Yeah, I mean, it's a good question about statistically. Statistics gave rise to all these AI and machine learning, but once they start doing that, they really don't think about statistics as much. But I certainly can use, there are lots of time series models, right? Time series models is a big part of, emerging part of, these AI and machine learning models. And so what I would, suggest is, there are models here. I may not be able to get into the details of it. There are lots of models, time series models, ARIMA models and VAR models that you can use in order to see how things are changing. And there are, if you write to me later, I'll send you some papers. There are papers written on as to how to use these models to predict what is the impact of your interventions and how their underlying preferences are also changing. So you can actually model those things. There are a wonderful class of time series models that can be used. Right? Is there any other questions, Shub?
No, not right now.
Okay, so let me go ahead and this gives you an idea of all the things. This is from a paper that we wrote a while ago. So you can see here the data that is available in the marketing environment. It could be structured data, internal data, and then you have CRM analytics, retail, segmentation, A/B testing, retargeting, geofencing, behavioral. And then as you go towards this, you have more unstructured and external data. Now, I didn't even talk about all the text analysis, text mining applications that are emerging, natural language processing, which are all part of the AI. And many of the trend analytics that you talked about just now, trend analytics as to how customers, underlying preferences are changing over time. There are time series models, sentiment analysis, attribution, which we talked about just now. And so many of these emerging, uses of marketing data use many of the AI applications. Now, very briefly, and I won't be able to really do justice to this, but the class of models that we try to look at in the machine learning area would be supervised and unsupervised, and then reinforcement learning. And and then of course, this is machine learning, characterized by this, and deep learning, of course, does very similar things. And I'm going to show you an example of deep learning dimensionality reduction problem, and I will talk about it very shortly. And so these are things that you can actually get from the web. There is supervised, unsupervised, semi-supervised. I'm going to, go over this because there's not much time, but if you want, you can come back to it later. And so what I want to do now is to spend some time on giving you a case study, right? So this is a case study that we have done, and I want to show you how this. So the idea here is, what we are trying to do is to understand the competitive market structure. So what do we mean by competitive market structure is understanding how different brands are competing in a product market, right? And then you want to identify the sub-markets within a market where competition, between the brands is very strong as compared to other brands which are outside of the boundary. Okay. Sometimes we say, given a focal brand, so if I know my brand, right? If I take a particular brand, I want to identify brands in the market. So let's say I take airline, Air India, or some airline I have, and this airline, which other airlines does it compete with very strongly, right? There are certain other airlines with which this airline may compete very strongly. So with the other airlines, it may not be as strong. So I want to find out the competitive structure. And again, we are using data from, digital marketing context. So the data that we have for this particular example is from social media platforms, Facebook and Instagram. And basically what the data is like, right? So if somebody says, I like a particular brand, then I use that in order to, so let me give you, so this is me, PK, I like Marriott, and in Facebook, I said, I like this brand. And then I saw a post from, let's say Walmart, and then I also liked Walmart. And I might like another brand here, which could be something about R&J Sports or something like that. So, the idea is many of customers, they engage with brands on Facebook and Instagram, and they put likes on it. Sometimes they put comments on it. Sometimes they may share it. So this is the data that we have, right? So we have lots and lots of information on users and the users interacting with different brands, right? So it's a bipartite network. So if you think of this as a network where there is a customer or a user interacting with brands. And so the same brand may be liked by somebody else. For example, Shub may be liking the same brand, Marriott, all right? So I have all this information, and this is the the data that we work with. And so what we are trying to do here is, hey, if you take all this high level, brand level data, how does the structure look like, right? So that's the question that we have. And so what we do here is this. So we take the data from Facebook. So we use the Facebook data, millions of data, right? And then we construct the network. So here is a brand and here is a user, the B1. So this is the nature of data that we have. And this is fed into a deep autoencoder, which is a deep learning technique. So what it really does, and I'll talk a little bit about that. So it will take all the data, and what it does is it takes all the relationship that is inherent in the data and then tries to represent it in a smaller dimension. Here I'm taking 3 dimension, for example. So I'm placing B1, B2, B3, and all these other, into many of these areas, right? And if I do that, what does that mean? It means that B1 and U1 are close, so they must be related to each other. They like, B1 likes U1 likes B1, right? So close. U2 and B2 are. So basically, the representation here actually captures many of the things that you're seeing in the network, right? And so then what you do is you take this and then you feed it into a mapping software in order to create this market structure that you see. So this is the market structure. Essentially what it does is it takes all the brands that you've interacted with and puts it in the map there. And the map is sort of, the dots, each of the dot is a brand, and they are located in this map, and that tells you something more about how these brands are close to each other or away from each other, right? So now let me look at, so what we are using is a deep autoencoder, which has been used in the context of image, mainly the image, to take away, what do you call noises in the image. So you have an input image, and the input image is, the information in the input image is actually crunched up and stored into a very small latent space. And usually the space dimension is about 300. And then it is encoded. This is encoding and this is decoding. And the decoding part is to create the reconstructed image, which should look like what you had as input, except that the noises have been taken out of it. So here is an example. So you can see here the input image has this thing in the eye, cross in the eye. And so you put it in the autoencoder and decode it, and the reconstructed input has taken away all that noise that you have. And of course, if you look at this image, the image has lost some sharpness, the quality that was inherent here. But then you have also taken away the noise. But what you have essentially done is you have captured the basic structure of the image and taken away the noise. And this is basically what we do with the data that we have, right? So we do the same technique. So what we do is we take all the data. This is all the bipartite network data that we had. We encode it. We create a bottleneck, right? So this is a compressed low dimensional representation. This is the dimensionality reduction that I talked about. And then you decode it and you get the re-instructed input. And the idea here is once I get the information in a very crunched up form, I can take that information and use a mapping software and then get the market structure. So let me show you. So this is the data collection. We looked at a list of US brands and followers on social bakers. 25 different categories, brands are our focus. And then you use the Graph API to collect all the user brand interactions, posts, comments, likes, and shares. This was 1 year data, 2017 to 18. And you can see here the number of brands is 5,500 approximately. Number of users is 25 million. 31 million unique interactions, and number of interactions is about 108 million. So we have 108 million data points here. So the interaction, that is the U1 liking, user 1 liking B1, user 1 liking B2, and so on. So that's about 108 million. So all this data is now being crunched up using this autoencoder idea. Now, once you have crunched it up, this is the what we get out of it. So this is the global market structure visualization. So you can see here, and these are all the categories as the brands categorize themselves in Facebook. And so this is auto, this is airlines, travel, software, sporting goods, retail goods, beverages, alcohol, accommodation, telecom, retail, beauty. So you can see here, I have some space here. It seems like all the auto brands are congregating here. These are number 2, maybe accommodation. And number 3 here is some other sporting good, retail, beverage, and number 4. So what you can do is, so this is about 5,500 brands that have been actually put in a map situation. And I can zoom into a particular area and look to see what is happening in that area. So this is one zooming that we did, right? So this is all the airline part. And you can see here, Air China, Air Nippon, Air New Zealand, China Eastern Airlines, LATAM, Lufthansa, many of the international airlines here, American United, Delta, the main airlines in the US, and then JetBlue, Southwest, the more of the discount airlines. And then you see here Disney Cruise, right? And then you have Frontier Airlines, Virgin America, Alaska, and Allegiant. So when you start looking at this map, so the idea of the mapping idea is, we are not looking at any particular industry. So when you start looking at a particular industry, you put a round, a boundary around it and say, well, I'm going to be looking at all the beverages, or I'm going to be looking at all the hotels, right? Or I'm going to look at all the airlines. Now, when you don't have any constraints and you get all the brands put together and then you put them in a map, then some interesting things pop up. What are these interesting things? You see here that JetBlue and Southwest are close to each other, and they're also close to Disney Cruise, which is not actually an airline, but it's a cruise line. So the idea here is that there are some customers who really like Southwest, also like Disney Cruise, right? So some of these hidden relationships with brands in very different categories start emerging when you start looking at this data set, right? And this is nothing but what people told me on Facebook. People said likes and so on and so forth. So basically, and then you can see here the hotel that pops up here is Hyatt, right? Hyatt is a hotel chain that pops up here, Disney Cruise here, JetBlue and Southwest. And you can see here the immediate idea is Disney Cruise and Hyatt, they're close by. Why is that? And it's because maybe there are underlying customers in that, or in Facebook at least, who like all these brands. So the people who like Hyatt also tend to like the Disney Cruise and Southwest and so on. So these hidden relationships then start providing you with some ideas as to, oh, maybe I can have some promotion, co-promotion with Southwest Airlines and Disney Cruise, or Disney Cruise and Hyatt can actually do a cross promotion. So those hidden relationships become evident. It's all from Facebook engagement data, right? And here is this is a hotel thing, which is kind of a mess here, so I'm not going to go into it. But what you can do here is, for each of the brand, focal brand, United and Southwest Airlines and Audi and Nissan, I can find out using the cosine similarity which are the closest brands: American, Delta, Lufthansa, Southwest. And you can see here for United, the closest is American, Delta, Lufthansa, and then Airfare Watchdog. And this is like a meta search site where you can get good deals, right? So that also is coming up here. Southwest, the same thing, Audi and Nissan. So you can see here that this is pretty good. We haven't put any structure on it. It is all based on what people have said on Facebook. And the mapping software is able to create clusters which are remarkably very informative as to what are the ones that are closest to your brand, right? Now, we did some case studies. We said, okay, Amazon acquired Whole Foods on August 2017, and Tesla delivers Model 3 on July 2017. So what we did was we did a pre versus a post, all right? Before Amazon acquired Whole Foods, how does the map look like? And after Amazon acquired Whole Food, what happened to the map structure? And you can see here, this tells you that these are the changes that occurred in terms of the cosine similarity. And so, for example, with Lowe's, Improvement, Office Depot, Best Buy, Amazon is moving away from those brands, that is most of the retail brands, and gets closer to Costco, Love with Food, Walmart. These are all the food brands, right? Grocery and food chains. So it has gotten closer to these brands and it's moved away from that, right? So that kind of shows what has happened. And here is Tesla Model 3 is basically a $35,000, Tesla usually sells for 70, 80,000. They decided to come up with a Model 3, which was a 35,000, more for the masses, so to say. And what happened is because of that move, entry, the perception changes. And so you can see here, they are moving away from Maserati, BMW, Mercedes. They're moving away from all these high level, one of the luxury brands, and gets close to, brands like Kia Motors, Mazda, Hyundai, Toyota, and so on, right? So this is an additional thing about, how these movements occur, how does consumers' perception changes about these brands, and it can be captured very nicely using these. And here is Auto Gallery, so before, where is Tesla? Tesla is here, before with BMW, all these other brands. And then when we move it, Tesla has moved a little bit here. Now in 2-dimensional, it is not very clearly, this is a 300 dimension map, 300 dimension space, where you have actually used this mapping software to bring it down to 2 dimensions. So it might be on that other dimension that you may see all that, but clearly it shows that there is movement as a result of, and we actually did all the analysis to ensure that it is statistically significant, all right? And here is, where is Amazon? Amazon is right here, along with, Office Depot, Home. And then after they bought Whole Food, Amazon is here. Whole Food brand is here, right? So you can see the movement that happens. And let's see how much do we, in terms of time. So I'm getting close to the end. So you can actually do visualization. And the nice thing about this is you can actually do a visual map. And I'm trying to see whether I can show you this visual map here. Let's see whether I'm able to. So are you able to see the visual map here? Are you able to see that? Yeah. Okay, so you can see here, this is a visual map. This is in GitHub, so you can actually go and check it out. So you can see here that you have all these 5,500 maps, and you can actually move your cursor and you can see what these brands are actually. This is McDavid USA, and this is Alfa Romero, Maserati, and I can actually go and zoom on it. And I say, well, I want to get zoomed. And I want to zoom in, and I can go zoom in as much as I want. The Carbon Express arrows, and so all these different brands. So I can just do zoom in as much as I want and get these relationships very well done. So you can see here that this is the output of it, right? So what is the input? The input is basically people going on Facebook and saying, I like this and like that, and then you take all that data. And so the main thing that I want to point out here is that what you have seen here is examples of how AI deep learning can be used in order to get insights which you otherwise cannot easily get when you have so many brands. For example, when you do analysis in your industry, you usually take another 10 or 15 brands that are close to you and then analyze it in a competitive intelligence viewpoint. But then, AI techniques allow you to really massive amount of massive number of brands can all be analyzed at the same time, and it will start giving you some insights which you otherwise will not be able to, get, if you were to use a very, smaller technique which doesn't allow you to analyze all these things. So this is the advantage of the scale that AI enables. The scale is tremendously high. I mean, I am taking 108 million data points here. I'm still able to get some insights in a two-dimensional map and try to show you how this whole thing works, right? So let me stop here and field some questions.
Right. We have a question from Shruti that is,
is that the question?
How do we use the AI techniques to target B2B customers? In a B2C scenario, we can analyze the consumer behavior, but how to replicate this for an organization?
Yeah, it's a good point. There are lots of B2B companies where you have to do, leads. You have to look at leads and then try to understand which leads to pursue, right? One of the things that you have to take into account is right that in B2C, you have a lot of data, you have, the scale is really high. Now, if you are working in a B2B company where you have limited number of, accounts to deal with, I wouldn't suggest, AI, all right? So the analogy is something like this. Suppose you want to go from Mumbai to Thane, then you take the local train, or take a car or something. But if you want to go from Mumbai to Delhi, you take the plane. So that's the same idea. So if you really don't have lots and lots of data, these techniques, especially for deep learning, it requires a lot of data points, right? And that's not really appropriate. Okay, so I would say, conventional techniques would still be very useful in the B2B if your number of accounts is low. But there are some cases, IIM Bangalore put out some cases on VMware. So where they were looking at, people coming to VMware, their websites, and, it's VMware is a B2B company, but they still have lots and lots of people coming to their website, and they want to do lead scoring and identify which customers to pursue. And they used, machine learning techniques in order to identify who should they go for. So it's not the question of B2B versus B2C. It is a question of the scale of data that you have, right? If the scale of data is really high, then you can use these techniques. But if the scale of data is not in that level, then the conventional techniques will work really well.
Right. Wonderful. Sriram has asked a question.
Sure.
Can you suggest use cases for AI in digital marketing for professional services, say consulting services, rather than in products?
Yeah, well, you need to know the context use cases. There are companies which work with, I might not be able to give you directly, but you can certainly look at. And again, as I said, if the scale of data is high, then these things become very useful. So, so instead of products and you say services, if you have data on services or perceptions of these services from consumers or, clients or whatever, and if you have that kind of data, you certainly can use these techniques, right? Offhand, I'm not able to tell you an example, right?
Sure. Shashi, you might want to unmute and ask the question. Shashi is
Shashi, he's an alum. I know him.
Yeah. I hope he's there.
So let's see. I see him here. He asked a question here.
Yeah.
Given that there are multiple dimensions while analyzing, we narrow down on 2 dimensions for visualization. This makes the dimensions we choose very important. Right. So it's not allowing him to unmute. So yeah, that's a good question. So what I would, so basically what it is this software that we have, which is TSNE, it comes up with the best representation of the larger dimension. So our large dimension space here is 300 dimension. The crunched up thing that we talked about is about 300 dimension. And so, the mapping software that you use on this 300 tries to display the points in such a way. It is not a direct translation of looking at, the data from 2 dimensions this way and then giving you, but it tries to sort of do some translations of the original dimensions and then try to present it in such a way that the variances are maximized, right? Somewhere, you try to do the maximal variance. Instead of all the points being close and crunched up, it tries to maximize the variance across the points. But the problem that you're saying, there'll still be a problem in the sense that, maybe if I looked at it another way, it might look. So what we suggest to do is that you use the actual distances. So the actual distances that you see, in the case that I showed you, they were getting closer, some of the reds and the greens. Those are based on the actual distances between these points in the 300 dimension space. And you can use that in order to find out which are the closest one instead of using the map. The map is a visualization. It adds problems Now, there are other visualization tools. You don't have to use T-SNE. You can use, there are other techniques that are in computer science. I forget the name of it. We use a couple of other techniques. One is, of course, principal component analysis. We use that. And there is another technique that is also used in computer science in order to do visualization. We tried that. And they give you very similar. Overall, all the idea is the same. They try to maximize so basically the idea is, if I give you a point, I want to show it in such a way that they are maximally separated, right? So that's what all these things do. And I agree, 2 points may look one on top of each other, and you may think that they are all on the same, they're very close to each other. But if you look at from the other dimension, there may be a big gap between them. Yeah. So that's why we have to use the real distances.
Great. Thank you so much, sir. It's a very interesting concept that you have presented, and I can think of a lot of value cases for this in the industry. Just a very short follow-up.
Sure.
Have you been able to implement it anywhere to bring about, any of those value cases to life?
Yeah, in fact, I have a paper that is coming out in Journal of Marketing, and as I showed you this visualization, so they pushed us to make the visualization, and we did the visualization. And you can go, it's a public, you can go and look at the visualization yourself. And if you want to do something like this, and if you have the data, we certainly can talk. And, we have all the software done, and we just have to redo it on a new data set. That's it.
Perfect. Great. Thank you so much, sir.
Very welcome. Good having you here, Shashi.
Wonderful. We have one more question from Rakshit. It's, how is deep learning being utilized in healthcare industry given the current scenario?
Okay, it's a good question. I have a son who works in the healthcare industry. All right, so he, of course, he's not a marketer. He's a finance guy. So there are companies, and he's working in West Coast, so what they do is they get a lot of patient data. So they get a humongous amount of patient data, and all the pharma companies really need data on their patients in order to do trials and comorbidities and so on and so forth. And so what this company does is they get the patient data, and of course they take care of all the they have to be working under very strict guidelines because this data is very private, and they have a lot of clauses, HIPAA clauses, and so on. But what they essentially do is they use a lot of machine learning and AI techniques to create slices, segments, so to say, like we talked about, segments of very type of customers, and then they identify these customers, and then they sell these products to. So they're basically a data shop, get all the data, use these things, and create products from the data, and in order to sell to specific, pharma companies or insurance companies and so on, who might want to know more about, how patients. So the patient data also has behavior data and other things. So I think, healthcare is one area where it's a tremendous amount of analysis can be done, and we ourselves have in our school a Center for Health Informatics, CHIGS it's called, and we have senior professors working on this area. And so you may want to just check out our website, and what I'm telling you is one example. They have tons of examples on their website as to what they do with AI. In fact, they have launched an AI and healthcare course online. You may want to check it out. It has some information on that. A big area. Yeah.
Wonderful. We don't have any more questions at this point. I think, Manish, would you like to have a few words, and then we can close? It's close to the time we have.
Right.
Yeah. So I can tell you it was very insightful for me. Sir, till now, the AI means going to Google and searching. So Google is using the algorithm, that's the AI. When you go to, use the Uber or Ola, it tells me the destination automatically, which I have used earlier. That is AI. If I'm going and finding a location on the Google map, that's AI. So for me, that was the AI. Very, very probably from your perspective, very basic applications of AI. But what you talked about, is sizably different from what I had in mind. So what I learned today, and I think my friends learned today, is wherever there is a data, there is a potential opportunity to apply the AI to drive some amount of inferences or use the data to create the better customized experience for the customer, which I think everyone is looking for. Is that the right understanding, sir?
Yeah, you're very correct. And as I said, again, the techniques that you would use will depend upon the volume of data that you have.
Yeah.
And why some of this deep learning has become so big is we have tremendous amount of data that is being collected now, and we have computing power that has really, very high level of computing power. In the 1980s, we had neural nets. Why didn't neural net become, in fact, in the 1980s, AI started going down because the power of computing wasn't there, and also the amount of data that you needed to create this, it wasn't there. And so if you compare the 1980s to today, the only difference is, you have more layers in these neural network, right? And that's called deep, because they say, okay, when you have more and more layers, it's deep learning. And then you also have the computing power to really do these things. And I think one of the interesting things about this is, well, you can use AI wherever you want, and depending upon the data that you have. If you don't have enough data, machine learning techniques may be fine. But if you have large amount of data, then deep learning techniques will be useful. You're muted, Manish.
Sure. Sir, the last question I will ask you, before we just end here, is the privacy issue. Because a lot of people today are saying that you are collecting information without my permission, probably, or maybe with permission, which I didn't know. And you are using that in the multiple manner. You are kind of intruding in my home virtually and asking me the questions which I wouldn't like you to ask, honestly. So where does that line stop? Where is that line when you say this is a private information and this is not?
Yeah,
how do we handle that?
Yeah, no, there are no easy questions on that. Privacy is important, and I think people are getting more. People have done studies on privacy, and so what it is. I have a project that I do on privacy, trying to understand. The idea here is understanding what is it that predicts certain behavior well. So if I have like 10, let's say I have 100 characteristics of a particular person, like say Shubh, I know 100 things about Shubh. But among the 100 things that I know about Shubh, only 1 or 2 things are predictive of the behavior that I'm interested in. How many, let's say how many, products he was going to buy, if I know, right? If I want to predict how many products he's going to buy. And if I know two of his characteristics, I can predict this well. So what it says is, value of information for me is not all the 100 characteristics, but I'm really worried about only these 2 characteristics, right? And so those 2 characteristics, Shubh may be okay, you may say that's fine. And if they know about, my, whatever my habits of using this product and stuff like that, that's not a big deal. But Shubh will be very upset if I take all the 100 characteristics that I know about him, and then he becomes, oh my gosh, they know everything about me, right? So the idea here is not to use all the information. People shouldn't even go and collect all the information on everybody. They should collect information which is very specific to what your product is. And once you establish a relationship with that customer, and customer feels that that information is actually providing them some customization, and usefulness, and I think then it becomes less of a problem. The problem becomes you indiscriminately collect all the information about wherever he is going, whatever he's doing, and so on. Then it becomes a problem. Then people get very upset. So I think it's a question of understanding what value information has for you, and that value has to have similar value for the customer. If it's a win-win situation, people wouldn't mind. It is, if you're going to be using that information to charge more for Shubh is going to be concerned, right? So I think that is where the line is drawn.
Brilliant, sir. Thank you very much for taking time out from a busy schedule and share with us the amazing perspective. And it was a phenomenal learning. Thank you very much, sir.
Thank you again. All right.
Thank you. Thank you,
I would
Dr.
love to see some of you.
Thank you, everyone.
And Shashi, nice seeing you. We'll be in touch.
Thank you.
Take care.
Thank you, everybody. Have a great
Bye-bye.
Thank you.